as I already said, and probably many of you know her, she's an expert in data quality. She did her PhD in the Leipzig University, and then she was a postdoc in Stanford, and now postdoc in the data science group in the University of Maastricht. And with this, the stage is yours. Thank you very much for coming.
Thanks. So I can only see it there. Yes. Display. Okay, thanks. How much time do I have? Okay, hi everyone. I am Amrapali Zaveri, a postdoc at the Institute of Data Science that was just formed 2 years ago at the University of Maastricht in Netherlands. And first I'd like to thank Christina and Claudia for inviting me for this workshop, especially because during my PhD, which I actually did in the University of Leipzig, not far from here, I focused on data quality, specifically on linked data quality, and I'm going to talk to you a bit about that. So we're in this era of data science where we have a wealth of data that's available on the web, that's open, and an increasing number of discoveries, scientific discoveries, are being made using other people's data. All this is great. But the problem is data quality. Data quality affects or costs the US economy around $3.1 trillion a year. And it reflects the paradigm that we have, garbage in, garbage out. Even though we have all these exciting technologies, machine learning, artificial intelligence, we need to have good quality data to be used as input so that we get meaningful results from these applications. So as part of my PhD, I focused on data quality assessment. And with Anisa Rula, who was a PhD student at the University of Milano, we did a systematic literature review of all different articles that either addressed data quality problems, who produced tools, who had matrix dimensions. So what I'm going to present here is the result of our survey, which took 3 years for us to get that paper published. So as a part of this systematic literature review, we looked at all different articles, and we came up with a core set of 30 articles, some of which were published at conferences, some were at journals, and there was a very relevant one, which was a master thesis, which we decided to include as well. And as part of our qualitative analysis of these 30 articles, we unified all the different data quality dimensions and matrix and came up with our set of our proposed 18 dimensions and 69 matrix. So this is the paper, which is published in the Semantic Web Journal, which has over 300 citations now. And this figure, which I will go into detail later, is an overview of those 18 quality dimensions. So I highly recommend you to take a look at the paper to see the definitions that we unified across all different papers for each quality dimension, and all the 69 matrix that have been listed out there. But before that, what we also see, and what Christina was also mentioning, we looked at what is data quality, how is it defined? And of course, we weren't the first ones. Data quality has been defined by Duran et al. in 1974, in fact, to be fitness for use. And what that basically means is that data quality is very specific to a particular use case. What that means is a particular dimension may be applicable for a particular use case, but may not be applicable for another use case. That said, even a particular data set, the quality of a data set really depends on the use case. So a data set A might be complete versus more complete versus data set B, but data set A would be more relevant for a particular use case. And what we also looked at is how do we define dimensions and matrix of data quality. So data quality dimension we define as a characteristic of a data set. For example, completeness, consistency. Those are data quality dimensions. And those are the 18 ones that we found. And a metric we define as a measure or an indicator for measuring a quality dimension. And what is the goal of quality assessment? And of course, on my slides, you will see that this was mainly done for linked data quality. We focused on that. But of course, there are dimensions and matrix out there which are applicable to other forms of data as well. So the goal of linked data quality assessment is not only to assess, but also to improve and fix those quality dimensions. And especially in linked data, these quality issues arise due to different reasons. They could be in the source data set. For example, it could be in Wikipedia. The quality issue may be arising in Wikipedia, and the quality issue gets detected in DBpedia. Or they may be results from imperfections of the data integration or the data conversion process while converting from a legacy data source to the linked data source, for example. Or these quality issues reveal themselves only after data integration. So when you integrate maybe different languages of Wikidata, you see that there are differences in values of the population, for example, for a particular city. And so in a sense, data cleaning, data cleansing, quality assessment, it's relevant for both the original data set as well as this integrated data set. And the problem then arises is that when you have a quality issue in your source data set, it gets propagated when you integrate large data sets. So coming back to the linked data quality dimensions, what we also did was we grouped them into these 4 categories. Accessibility dimensions, for example, availability, licensing, interlinking. We grouped them under accessibility dimensions. Then there was representation dimensions, such as representational conciseness, interoperability, and contextual and intrinsic were further such groups which were actually taken from the database world, where you have context-specific dimensions such as trustworthiness, timeliness, and then context-independent dimensions such as the syntactic validity of a data set, the semantic accuracy. And as part of our qualitative analysis of this survey, those lines that you see between them, those were indications that these 2 dimensions may be related to one another. So to say that interlinking and semantic accuracy, for example, that you see there, um, to say that even though there may be two facts that are interlinked, the semantic accuracy of it may be poor in the sense that the relation that we say that it's same as or it's related to may be incorrect. So even though it might score points in the interlinking because there an interlink exists, the accuracy of the semantics of that link may be poor. So there are always these, there's a balance between the dimension, and then that said goes back to our definition of the fitness for use to say that one data quality dimension may be more important than another quality dimension in a particular use case. And what we also did here is the dimensions that are marked with an asterisk are the ones that are very specific to linked data quality, whereas all the others are also applicable to open data sets or to databases. So interlinking is something that's very specific to linked data quality, for example. So what I want to do in the next few slides is to just give you a taste of what kind of matrix we identified for some of these dimensions, but again, the entire list is in the paper. For example, for the accessibility dimensions, we have availability as one quality dimension. And that can be measured by accessibility of the SPARQL endpoint, dereferenceability of the URIs. So those are some kind of measures that you can have. As I mentioned, then you have interlinking dimension where you detect the existence and usage of external URIs as a measure that that data set is interlinked. But you can also detect inlinks or backlinks, which means a certain resource is also linked to a resource within the data set. So those kind of interlinks can also be detected. And then we have these definitions for the dimensions. So interlinking we define as the degree to which entities that represent the same concept are linked to each other, be it within or between two or more data sources. Another example of another group of dimension of intrinsic category is syntactic validity. So we have syntactic validity in terms of RDF, so that it's the degree to which it conforms to the syntax, so that you have all the specification of the serialized format is followed. And then these can be measured either by using validators. You have a lot of RDF validators out there. And I put crowdsourcing out there, which I'm going to come to later, which is also another study I did with using non-experts to assess the quality of DBpedia. And that was to give them micro tasks to detect whether whether the data type is correct, whether the language tag is correct, and those were micro tasks, which I have examples for later. And then, of course, you have syntactic rules where now I'm sure most of you know about checks and shackle, where you have these rules that you can use to validate your data set. And this, like Christina was saying, another thing that all of us are interested in is measuring the completeness of a data set, which is kind of tricky when you talk about linked data quality because of the open and closed world assumption. But assuming a closed world assumption, we found that in those 30 articles, there were papers that had one or more of these 4 matrix, which was schema completeness, so ontology completeness, property completeness, population, which is the value completeness. So when you measure whether the value in Wikipedia and the value in DBpedia, whether the value in DBpedia is complete with respect to Wikipedia, and interlinking completeness. So these were kind of the matrix to measure the completeness dimension. What was also done during this survey is 8 of these 30 articles contained tools to measure these dimensions. And we did an analysis, and this is just a showcase of what kind of tools are out there, automated or semi-automated, to assess the quality of link data. So one of them was RDF unit, which was developed by one of my colleagues at University of Leipzig. And it's a RDF unit testing suite that is basically using using shape expressions to assess, and then it measures the syntactic validity of data sets, but syntactic and semantic accuracy of data sets, but mainly it looks at the consistency dimension. So the logical inconsistencies in a data set. And what it does is it not only assesses and assesses the consistency in a data set based on the ontology, but what's really important to note here is as output, it produces the exact triple where that inconsistency lies. So that's really useful when we talk about improvement of data sets. So you can actually go and fix that exact triple and improve the quality of the data set, which is really important when we want to talk about the whole, linked data life cycle. Right, and then the other tool that I developed during my PhD and evaluated the use of crowdsourcing. So is everyone aware of crowdsourcing? Non-expert crowds. Okay, good. So what we did was we looked at 3 different data quality issues, mainly in DBpedia. One was incorrect object value. Second was incorrect data type. And third was incorrect interlink. So these 3 quality issues we converted into micro tasks. And the micro tasks basically looked like the value, for example, for the incorrect object value, the value from Wikipedia and the value from DBpedia. And all the worker had to do was to tell us whether the values are complete or correct. So it was a very, micro task. It can be done by anyone, by even those who are not conversant with RDF. And this would give us a measure. So for example, there were incomplete object values when it came to birth dates. Because in Wikipedia, you have these birth dates such as 3 Jan. And then and this is then a measure of the problem when it comes to conversion, that it converts to maybe just 3 because it doesn't detect the Jan in the January. So then we have these, humans kind of help us validate or identify the quality issues that occur there. And then we had, for example, then we had data types. So then if the language tag was correct, so we found that there was a Chinese character that was tagged with the English language tag. So then again, we could, the humans could, assess these kind of quality issues. And then we had incorrect interlink, where we gave them the link to the resource, and then the Wikipedia have these links to external sources, right? To external pages. And we asked them whether the link is relevant to that resource. Yes or no? Apart from that, so that was strictly non-experts. So that was using Amazon Mechanical Turk, paid them 5 cents per task, and gave them all these tasks to do. But on the other hand, what we also did was this interface that you see here, we call it Triple Checkmate. It's a tool where we launched it as a contest. So we invited those people who were mainly conversant with RDF. So we basically published it in the public LOD mailing list, and we invited people, and then we said, okay, the person who identifies the most amount of errors wins a Galaxy tab. So that was their incentive. And we gave them the same. So here, they come in, they log in, they can choose, they can either choose which resource they want to assess, or randomly a resource gets assigned to them. And they are presented with all the triples belonging to that resource. And what they have to do is to assess for each resource, say, does there occur an error in it, in that column? And if they click yes, they are presented with these predefined quality issues that we identified were the most frequently occurring, and then they had to choose which quality error that is. And what was interesting is that we compared the results from these RDF experts versus the non-experts from the crowdsourcing. So out of those 3 quality errors that we compared against, for the data type, so for the incorrect object value and for the incorrect interlink, the non-expert crowd performed better. And and for the incorrect data type, the RDF experts performed better, understandably, because they knew of the other data types that were possible, right? And what we found here is it's cognitively challenging task if there are many triples in there, of course. And then there were some people who were, just clicking on those triples which did not have an error as well. So we did a manual check of those as well. That was interesting, and it goes to show that, experts as well as non-experts are required in the process. It's not that the non-experts could identify all of those errors. So they can work in unison, and then those errors that the non-experts cannot identify can be filtered out to go to the experts, so that they have a smaller set to work with. So that was one of the other tools. Then there's a tool developed by Jeremy de Battista from, he was in the University of Bonn. This tool called Lutzu, which takes as input RDF data set, and it assesses the quality of that data set based on not all of those 18 quality dimensions. I think, if I remember correctly, 8 of those quality dimensions. And then you can, you get a report of each matrix, each triple, which assesses the quality score for each of them. And of course, there was this laundromat that also came about, which was automatically crawling over LOD cloud and cleaning it and making it available. So that was another thing that was recently published. Another means of quality assessment was developed by Anastasia from University of Ghent, where they looked at the mapping quality. So they developed a tool called RDF mapping language, and before you publish or you convert the data set and publish it as linked data or publish it openly, they developed a tool called the RML validator, which basically looked at the RML mapping file, where you're mapping your value or your column to a property from your CSV to RDF. So it assesses that for completeness, it assesses that for consistency, so that you get a report before you publish it and then can fix it right there as well. And then, of course, recently what came about was the Shex and Shackle validation, the shape expression language, where you can define these rules, define these shapes which are tailored to your data set, and then assess the quality of your data set based on those. Right, so now you have an overview of the different data quality dimensions. There are different metrics to assess these quality dimensions. There are different tools and methodologies available. But what is lacking, or what I haven't seen so far, is closing the cycle of data quality assessment, improvement, and then republishing it. Even after assessment, what usually happens is, okay, you have this report of your data quality issues, but fixing the original data set and then republishing it, that's something that's really lacking, and that's something that's also lacking in tools that are available. So data quality improvement basically means that you need to go to the root cause analysis. Like I said, RDF unit publishes the exact triple where you identify that data quality issue, which is extremely crucial for you to know, okay, that's where the inconsistency lies in my ontology, which you can then use to generalize and then improve the next batch of releases that come out. So that also means that the data quality assessment should be an iterative process. It should be a continuous process at regular intervals, so that you assess and improve the quality of your data set as and when new data comes in, which can, of course, bring in errors. And what is also important is to ensure not only that the data quality is high, but also the metadata associated with your data is of high quality. So one of the other outputs of our survey, which was the W3C data quality vocabulary, where the same kind of structure was used with the category, the dimension, metric, data set, and the quality measurement, where you can structure and semantically represent your data quality results and attach it to your data set, so that when a user wants to use your data set, they can even query your quality issues, your quality reports, or your quality results, and identify which data set is valuable for their particular use case. So if you have a standardized RDF structured quality report using the W3C data quality vocabulary attached to your data set. So this is again published, and Now I want to talk a little bit about metadata quality, which is equally important. And um, so you have these, I work a lot with biological data sets, and these have a lot of metadata associated with them. So not only in the data themselves, the actual experimental data that the biologists publish, but the metadata associated, so what organism was used, what was the disease, what was the tissue, what was the age of the organism. These kind of metadata also is very important to search and retrieve relevant data sets for your use case. And this is an example of poor quality metadata where you have 31 different ways of just writing age. So something as simple as age, there are different ways. There's age bracket years, age bracket months, age of patient. So when someone wants to query a database with the same keyword, they miss out on all these valuable information because of these different variants. And that is also a big problem when we talk about reproducibility. And this was a paper that this was published in Science magazine, where AI now faces a big reproducibility crisis. And that alludes to not only the data being of poor quality, which is used as input in these AI applications, but also that the metadata is extremely poor. There is no, out of 400 AI papers that they analyzed, only 6% actually associated the code that they actually used. 30% only introduced or published the actual test data, and 54% published the pseudocode. So this really affects when you talk about this research cycle, when you talk from data to publication to research or reuse of other people's data. And we want to move away from this current paradigm of where we have new data, we collect it, we extract it, data quality assessment is missing also from there. You analyze it, you publish it, and that's it. That's the end of it. We want to move away from this paradigm. We want to enable reproducibility. We want to ensure that others can also validate your results based on the data that you produce. And we want to we want this to enable new hypotheses based on the data that's out there. So if we want to ever realize the full potential of all this data, all the content we have out there, and like you mentioned, you have a lot of people who want to import Wikidata, right, to use in their applications, then we must find ways to reduce the barrier to not only publish, but also to be able to find and reuse that data seamlessly in a responsible manner. Which is where these FAIR principles have been published in 2016, where these are set of principles and matrix to ensure that your data is maximally findable, accessible, interoperable, and reusable. So this is just but a subset of all the different data quality dimensions that we've seen, but they're very much related such that you can, this ensures that not only your data, but all digital research objects. So not only data sets, but also repositories, software code is of high quality. So it's going a little bit, beyond what we see beyond just data. And these are being developed and endorsed by researchers, publishers. Horizon 2020 is now making sure that all your data is going to be fair, and industry partners. So this is just something to also think about. And to end with, I'd like to say that, yeah, improving the fairness of your digital resources will increase their quality and improve their potential ease for reuse. So these are all the different kind of dimensions and matrix that you need to keep in mind when you talk about data quality. Thank you. Questions? Yeah. So they are very much related for sure. The data quality dimensions are mainly to do with the data, but the FAIR principles, the findable, accessible, interoperable, reusable, they each have matrix, and those apply to not only data but also to repositories, software, your code. So they are related. It's just that there are different measures for each of them and different principles. But of course, they all, correspond to quality. Yeah.
Hello. So you defined the quality dimensions and the metrics. So do you have idea or a feeling where the biggest problems lie nowadays? So what quality dimension?
In terms of quality dimension,
Yes, for example, for Wikidata, Wikipedia, or similar resources, where do you see the biggest challenges?
the biggest challenges in terms of quality assessment is that, first of all, this is not done in an iterative process, right? So right now, if I want to go and find out the quality of DBpedia, there is no such report out there. So even I cannot say that, okay, DBpedia has low consistency versus high completeness. So it's a bigger problem out there. But that said, Jeremy is working on assessment of the linked open data quality assessment and trying to do this in an iterative process. The other thing is, again, it really depends on your use case. So even if DBpedia has a low completeness but high consistency of the data, it still might be valid for a particular use case. So it's not a clear answer out there that, okay, there's no one score to say that, yeah, DBpedia is 100% complete but 90% consistent. That's what's lacking, and that's what we need, actually. The other thing is those quality issues that we identified. We did go and change the conversion tool that was converting and causing these errors, where I talked about incompleteness in the object value, where it wasn't identifying as January and not completing the birth date. So we did that kind of improvement, but then it has to be an iterative process. So that's what's lacking. Yeah.
Sorry. Okay. Yeah, so just maybe to make it sure again for me, so it's there's no objective truth or universal truth about what data quality means. It's more subjective and dependent on the context, and so it's kind of really hard actually to find. For example, for Wikidata, it's an open database for everyone, and each person can have their own how do you call it, like objective or aim or something, or motivation. And so it's pretty hard to find like a universal data quality measurement or
So,
dimension?
yes and no. Um, first of all, I would say that this concept of having one score for data quality as a whole, I don't believe in that, because data quality, as we saw, is a multi-dimensional construct. That said, what we also did in the paper is for each metric, we tried to identify whether it's quantitative or qualitative. So there are, out of those 69 metrics, I don't remember the exact number, but there are quantitative metrics that you can assess for a data set, right? That you can say that it's whatever, 80% complete. There are, the syntactic validity is 100%, blah, blah, blah. In terms of the qualitative ones, those are very subjective. For example, trustworthiness. That's very, very subjective. That's difficult to quantify. And that then depends on your use case. So it's like a multi-dimensional, multi-matrix construct, which and I wouldn't say it's based on each person, it's based on very specific use cases.
Yeah, thank you very much for your talk. So I have a question. So from your experience, you were talking also about crowdsourcing, so that you ask people to evaluate the quality of specific triples. So in Wikidata, we have a very active community, also humans, so participating. So I'm wondering which of these, so from your experience, so if I see all these dimensions, for which of these dimensions are humans specifically needed for increasing the data quality?
So I would say for those that in general, of course, that the automated systems cannot identify these. So for example, those data types, for those language tags, for those incompleteness. So what we also did is we ran semi-automated method on those same quality issues. And we saw that the automated or semi-automated methods could not identify those quality issues that you need humans for. That said, those subjective or qualitative matrix are the ones where we need humans, right? And what we also say in our paper as a conclusion is humans and machines should work in unison, right? So the semi-automated, automated method can do a first run of the quality issues, but then you have humans verify it, check it, and those which are incorrect goes back into the machine to improve its accuracy, right? So it's a bit of both. But the question then arises, which I'm working on, is what is the optimal combination of humans and machines? Crowdsourcing, of course, you need to pay them. So doing it on a large scale can get expensive. So at what point, the question is, at what point do we not need the humans such that the machine has learned enough to do those quality assessments automatically? So that's something I'm working on right now, but yeah.